I'm on right now. Pardon the background noise, guys. It's Saturday night, we've got a family party, and I slipped away just to do a video or two. So here's what we got. I'm doing here problem 15.34. Guys, I need about 10 minutes. Problem 15.34. And the question is, what's the probability that a particle would be between 0.332A and 0.35A in a particle in a box? Okay, given that the wave function is defined as, there's two parts here, A and B. Root 2 over A sine pi x over A. Why is there no n here? Of course, it's just given in the question stem. It doesn't really matter why there's no n, but we typically have n pi x over A, right? You should ask yourself why why is there no n here? All right, so what's the probability that a particle is found in a net interval here? And so it's going to take this integral here to form 0.32a, 0.35a. I've done this a couple times in class, so I'm giving a little bit less explanation. Sine squared, let's put this 2a out front. Sine squared pi x over a. Why I set this up like this, I'm really dying to tell you. I'm going to tell you now, right? The probability is going to be a to b of psi star psi dx. That's the probability in one dimension. Okay, so that's what I did here. I just took that out front, took the root 2 over a out front, multiplied them together and got 2 over a. Okay, so what I need to know now is just a standard integral. This is just something that I find in the front page of my exam or in the integral table. And so I'm going to map this over to that. So it looks like I've got my b here is going to be that, right? And y, of course, is just x. So let's write this out. 2 over a. The y is just x, so it's x over 2 minus 1 over 4, and b is pi over a, so it's going to be pi over a sine 2 pi x over a. Okay, and this is from 0.35a to 0.32a. So I'm going to calculate this out. I'm going to go ahead and show it, though maybe if you didn't like this problem, this has probably already been answered for you. My guess is here. It's what you didn't like was somewhere upstream of this. But let's calculate this. 2 over a. X is 0.35a over 2 minus 1a 4 pi sine 2 pi times 0.35a over a, right, minus 0.32a over 2 minus a over 4 pi sine 2 pi times 0.32a over a. Okay, so let's go ahead and it looks like this 2 is going to cancel with that one, and I can take a 2 out of that. Look, this 2 is multiplied by all those things, right? So I can get rid of that 2, and make that a 2 pi. Let's do that. And this a is going to cancel with that, and these two a's are going to cancel there, right? Those are all going to cancel. So let me get rid of that first term and say this is 0.35 minus this is 0.35, yeah, 0.35 minus the a's canceled, and this becomes 1 over 2 pi sine, those a's cancel, 2 pi times 0.35. I'm going to go ahead and distribute that minus sign out. So this becomes minus 0.32 plus 1 over 2 pi sine 2 pi times 0.32. Okay? That minus that is 0.03, and then I've got to figure out what that is right there, minus this mess, plus that mess, which is that right there. Okay? Almost done. 2 enter pi times 0.35 times sine of that. 2 enter pi times divided by 2 pi gives me 0.129. Okay. And this one's going to be 2 enter pi times 2 pi 0.32 times 0.32 times that, sine of that now, and then divided by 2 pi. Enter pi times divided by 1.44. Okay, so this comes out to be 0.03 plus 4.52 times 10 to the negative 2. Alright, so I think that might be, is that off camera? Sorry about that. Alright, that might be all you need. I'm going to leave it at that, because the second one is the same thing, but it's a different wave function. And the third question is, compare this to the classical expectation. Actually, let's do that. Let's compare this to the classical probability. So it's 0.32 to 0.35. We're wondering what's the probability it's going to be in that region right there. So this is 0.03, right? And 0.03 over 1. The rest of the probability right there, 0.03. Do you see that? Oh, that's off camera, isn't it? 0.03 is the probability, because if this is 100% of the region, let's call it 1, and that's 0.32 to 0.35. The difference is 0.03. So that's the whole region right there. So the probability that in the classical is that. So it looks like the classical is 0.03 compared to this right here, which is the quantum mechanical. Why is that greater? Wow, good question. Why is that greater? Okay, hope that's helpful. I'll try to get these uploaded tonight, and hope you're doing well. Keep up the good work.